Awesome, cool. So let's get started. Thank you everyone for coming. You are in the AI Club meeting, and today's meeting is going to be an introduction to Python workshop with an introduction to machine learning application. The introduction to Python will be conducted by James and Aishwarya. They'll be talking a little bit about how to get started with that, and then I'll be leading the machine learning part where we talk a little bit about linear regression. Yeah, but let's get started. And in this workshop, we're going to be using Google Colab. James, if you want to get them, show them how to get started with Google Colab right before you get to coding, that might be a good idea.
Let's see. It's pretty easy. So if we go to Google Colab, and let's say we want to make a new notebook here, specifically for this project. And we'll title this Intro to AI, not AI, Python. My bad. And there we have it. Okay, so let's get started. Thank you, Adwith, for the introduction, and thank you all for attending. My name is James, and I am going to teach you how to bake a pizza, a Python pizza. Yes? All right. If there's no further questions, please make yourselves at home because you most likely are at home. And let's get started. In Python, we don't need to declare a primitive data type for our variables as it's a dynamically typed language. So our first ingredients are some primitive data types, of which Python has 4. The int, the float, the boolean, and the string. And when we combine them, you see that we here get a type error. Well, thank you all for coming. We'll see you next week. Just kidding, don't leave yet. So let's take a look at the humble int. Unassuming but not unloved. Does anyone here know?
Lunges, no? Squat.
Rishabh, can you mute, please?
I have forcefully muted that man. Does anyone here know what this value represents? You can unmute your mic and talk freely as much as you want.
The integer limit?
That's right. It is the integer limit. So if I were to declare a as the integer limit, and then I print a plus 1, do you think it'll still compile? Well, the answer is yes, because in Python, integers are unbounded. And integers don't even have to be in base 10 either. We can have A and A1 be 0xf and 0b11, signifying that they are hexadecimal and binaries, and they can be many other things too. So let's print these values. And you'll see that they are 15 and 3 for 0xf and 0b11. Now, you can tell, though, that they are still classified as our ordinary humble integers, class int, and any operations we do will show that they are also treated as such. Another way that we can express hex and binaries in Python and many other things is to use functions like this, where we have the hex, binary, and hex again function on different values. And you'll see that the hex of 10 is 0xa, the binary of 10, 1010, and the hex of 1010 in binary still converts to 0xa. But let's try something like this. Int of hex of 10. This is going to throw us an error. And so let's check the data type of the above commands by using the type function. We see that both of these methods have returned strings. So this is just something to be careful about. Meanwhile, if I were to say print the type of 0xa instead of hex of 10 and 0b1010 instead of binary of 10, this works fine because these will be of class int. Moving on, we are going to evolve our integer into a float. So let's have a be float a, and then when we print this, you'll see that it is now 15.0. And if we print the class, you'll see it is now of the class float. Let's make a more interesting number. Let's have it be 345. Print a. Let's have a be 15.2469. That is interesting. All right, well, a is now going to be equal to 15.4938. And the whole reason why I want to do this is to show you the handy round function. Let's round a to, say, 3 decimal places. This will now be 15.494, a very handy function. Speaking of some handy functions, let's move on to some basic math operations you might use. If I were to show you this function, it's pretty easy to know what this will result in. The power of 5 and 2 is 25. But what if I do something like this? Does anyone have a guess on what this will be? Okay, so this will actually equal 5 because this operation in Python is 5 to the power of 2 modulo 10. And the reason why Python has this particular function is that it's often faster to calculate the modulo of a function without having to multiply 5 by 5 in this case, but also by a even higher exponent. And doing so will save a lot of time, especially with a very big number. Python has a lot of these interesting methods available. You'll learn more if you code more with it. And let's try something else now. Say we want to iterate between 2 integers, which is something we commonly do if we're traversing data structures like a list. It's as easy as print a range of, well, actually, let's do this. Print list of range 5. Don't worry, we'll touch on lists soon enough. And you can see that this creates a list of the range 0 to 5. And let's try going between 5 and 10. Now we can set the bounds to 5 and our upper bound to 11 so that it ends at 10. With this function, we can either set the size of our increments. So say we want to go from 5 to 50 in increments of 5. And this will let us do just that. By now, you've all gotten familiar with the print statement. Print this, print that. It's so boring, right? Well, what if I tell you that you can spice up the print statements with some print formatters that you can go impress your friends with? Please don't actually do that. They might stop inviting you to their parties. So let's set a back to 15.12345. And this time we want to print a float value rounded to 2 decimal places. We can do that with print float is equal to modulo to signify a value, and then 0.2f, which means a float value, and rounded to this 2 decimal places. For our next section, let me just add in a few more code blocks. We're going to convert a into an int because we require an integer input. Now let's print the hexadecimal and exponential conversions of a, which is currently 15. We can do that with this function. Print hexadecimal equals modulo x. And mind you, you don't actually need this. This is just flavoring. But what's important is this modulo symbol. So hexadecimal is x, exponential is e, and we set the values as a for x and then a for e with this line. And if we print this, we'll see that a, 15, is equal to hexadecimal f and exponential 1.5 e to the 1. We can print a string by writing print string is equal to modulo s, and we say s being never going to give. So this will print never going to give. And then we can also print things multiple times. So let's take that same line and, well, actually let me illustrate this a bit better by first adding even more code sections so I have more room. Let's print I can't wait for the inevitable robot revolution new line character 5 times. And we can do this with the ×5 option, ×5 that we put at the end of this line. And this will print it 5 times. It's very handy if you want to print something repeatedly, but this works for things that are outside the print functions too. So say you want to maybe create an array of 5 repeated blocks of a certain digit or something. So this is a good place to start talking about strings. There's a few interesting ways to assign values in Python. We can do this to assign multiple variables the same value. And because Python is dynamically typed, assigning a string value to a variable we previously used to store an integer is possible. Let's print this. And you'll see that both a and a2 are now equal to echo. We can also assign different variables different values in this manner, where a will be assigned to u and a1 assigned to up. If we print this, a is u, a1 is up. It's very handy if you're just typing some quick scripts or anything in the future. Python has a lot of functions for formatting strings. Let's take a look at some of them. Let's use this as our sample string. Hello from the other side of the world. For example, we can count the occurrences of a word, say the. Well, if we run this now, you'll see that it's going to return 0 because this string is capitalized. So the first thing we want to do is lower the entire string with the string.lower function. And then we're going to capitalize the first character of the string with capitalize. And then let's print string 1 to see what it currently is. So you'll see that it's now all lowercase with the first character capitalized. And let's run the first query again. Now you'll see that the occurs 3 times because 1, 2, and the third in other. So this is something else you want to be careful of when you're doing something similar in your own projects. We can use the string index function in order to, say, find the position of a certain substring. In this case, let's use from. And you'll see that this returns 6. 0, 1, 2, 3, 4, 5, 6. It's very handy. Now let's try something a bit more difficult by splitting the string using string.split and the empty space, the blank space character as the delimiter. We're going to save this into string2, and then we're going to print string2 to show you that string2 is now a array of all the words from string1, except separate, but cut off by the blank space. Let's go ahead and fuse this back together with join. Join will let us take this blank space character and append it between each instance of string2. So now we have hello from the other side of the world again. Lastly, we can use shift to shift a string. We can use center to shift a string, which paths a string to the provided length with a character of our choosing, or alternatively, a blank space if not set. In this case, let's use an asterisk so it's a bit more clear. So we're going to set the string length to be 50 characters long, and we want all empty spaces to be padded with asterisk. And let's print that. And you'll see hello from the other side of the world, except there's now asterisk on the empty spaces to the left and right. And hello from the other side of the world is centered in the middle. Now, one last handy function is the replace method. So say we don't want these asterisks anymore. We can use the replace and use the target as the asterisk and replace it with nothing. And what we have here will be hello from the other side of the world again. Now you're all thoroughly introduced with some of the basics of Python. So I'm going to hand it off to my colleague Aishwarya to teach you about some more interesting stuff, data structures and loops.
Thanks, James.
Aishwarya.
I'll just start sharing my screen. Hi. So I'm assuming everyone can see my screen now. Okay, so to start off with, first of all, I'm going to talk about the data structure list. So in Python, you can simply declare a list as this, and we can check its type by printing the type of the list A. So yeah, so its type is a list. So we can have the list containing different types of elements. We can have a list which contains just numbers. And an example of that would be this, where my list just contains numbers 10, 20, 30. I can also have a list containing just strings. And an example of that would be my list 2. So this is my list 1, this is my list 2. So a list in Python does not need to have only similar data types, as in it can also have a mixture of integers, strings, etc. And I can show, and one example would be so I could, for example, I can use the method append, and I can append the number 2 to the list 2. And on doing so, I would get this result. So if you can see here, the number 2 has been appended to the end of this list 2. We can also have nested lists, as in a list containing 2 or more lists. A good example of that would be now, as you can see, X is a list containing the strings AI and club. Y is a list containing the strings Python and workshop. And then we're declaring that Z is another list which contains X and Y. Now, when I print Z, as expected, it's going to throw an error. So the reason is I forgot my brackets. So yeah, so now Z is a nested list in which it contains the first list AI club and the second one Python workshop. Now, if I were to access an element, or let's say I want to access AI, what I would do is I would first declare my list, then I would say access the first list, so that would be 0. And then I'm telling it to access the first element, which would also be 0. This gives me AI. Now I can also access the second element, club, and so on. I can also do this. So this is how we can access. So I kind of showed you how to access a list, but then I went ahead and did it for a nested loop. We could have also done this simply for the list 2 itself. Which gives us intro. So this is just basic operation on lists, and this is just to show you how you can declare different types of lists. Lists are the most used in Python, and they're you can easily perform most of the operations on them, so they're widely preferred. In addition to lists, we also have arrays. And for arrays, we would have to import the module arrays before we could even work on it. And once we do that, we can declare an array like this. So here, B is an array of type integer. So whatever data type of array you want, you have to declare that right here. So if I could have a D for double, where I would declare all of this to be doubles. And let's say I print my array B, I would get the following. Oh wait, I forgot to run this. Yep. So now all of these are doubles. So in this way, we can construct arrays, and we can also access different elements in arrays as such. So I could just say 2, and it would give me the element in the index 2, which is 3.0. And so let's say I want to print the index of the first occurrence of something. As in, let's say I want to print the index of the first time 2.0 occurs. So I could have another, let's say I have another array where I have 7, and then I have 4, and then I have 3. So if you can see when I run this, and then I print it. Yeah, so there are 2 3.0s. So if I wanted to find out the first occurrence of a 3.0, I could do my array b dot index, and I would want to know the index of my double digit, which is 3.0. And it gives me the index, which is 2. So this is 0, this is 1, and this is 2. So this is the first occurrence. So this is one useful thing that you can have with arrays. So next, moving on, I would like to talk about loops. And the first loop that I would like to talk about is a while loop. So you could have a simple while loop such as this one, where I'm declaring a variable count, which I've initialized to 0. And I'm saying that while my count is less than 3, I'm going to do the following. And in each loop, I am incrementing the count by 1, and I'm saying print. So if I run this, it would print hello AI club 3 times. Now I could also simply make the count 4, and I could say that while count is greater than 0 to run this loop. And instead of incrementing, I could decrement this, and I could run this, which would then print it 4 times. So this is a simple while loop. One thing to keep in mind while you're declaring loops of any kind in Python is to have this indentation. So if I had simply written it like this, it would throw an error. So having an indented code is extremely, extremely important. In Python, we don't really use brackets, but having the code indented is very important. And you should also not miss this semicolon. So this is a simple while loop. You could also have a very simple for loop. So like James mentioned, where he showed you the range, here in this for loop, I'm declaring that for I, which is a number here in the range from 0 to n, and here I've declared n is equal to 4. I'm saying that let's print I. So this would give me this output. Now I could simply say in the range of n, and would also give me the same. So range by default would start with 0. If I do not want this to start with 0, I could simply declare 1 comma n, and it would print 1, 2, 3. So this is how a for loop would work, a very simple for loop. So let's say one cool thing that we can do in Python is we can iterate through a list. So one example is we have our list 2, right? So we could iterate through it. So this prints out every single element in my list 2. And this is extremely useful when we're doing any kind of manipulations while writing code. This would be very easy for us to access the elements in the list. So that's one useful thing that you can do. And we can also have nested for loops. So here I'm saying that for I in the range of 1 to 5, and for the j, which is in the range of I. So this is similar to in range of n. So I'm saying that print I, and then I'm saying the delimiter here is blank space, and then I'm also printing this so that it goes to the next line. So then I would have this pyramid shape of the numbers. So this is a very simple nested loop. You can have different kinds of nested loops. This is just one example. And yeah, so after this, I would like to talk about dictionaries. So a dictionary in Python can be declared as such. So where, so here 1 is the key and the string AI is the value. So we have 4 keys and 4 values. Now if I print the type of dictionary, so it gives me the class of dict. So this is a dictionary in Python. I can also have a dictionary of just strings, and this is how it would look. I can also have a mixed dictionary, as in I could have a dictionary containing not just key values of, a singular key and a singular value, but I could have one key having a subset of a list, or which would look something like this. So here, my first key is 1 and it has the value of the string AI, but then my second key is a number and it is corresponding to this entire list. So this is an example of a mixed dictionary, and I could access this by writing of 1. And when I do this, so it's telling me that for the key value of 1 in my dictionary 3, the value is this. So I could also access the first string. Yeah, AI. So here my key is the string 1 and my corresponding value is AI. After this, okay. So another way we can declare a dictionary and create one is, let's say I've declared a dictionary, which is dictionary 4, and I want to manually assign my key value pairs. So I could do this in this fashion. So I'm saying that for my key 0, I want the string AI to be value. For my key 2, I want the string club to be value. And for my final key 3, I want the value to be 1. So when I run this, and if I were to print my dictionary 4, I'd get the following dictionary. So in this way, we could declare it and then we could assign it on spot. So this is one way you can do it. So we've covered basically arrays, lists, dictionaries, and loops, for loop and while loop. Now, one useful thing to learn in Python would be how to declare a function. And I would like to show you how to declare a really simple function. So the following function that I'm showing you is for finding out whether a given number is even or odd. So I would write DEF for definition. I would give the name and I'd give the number of parameters that I would like to pass. So the cool thing in Python is you don't have to specify what is the integer type or what is the data type of your parameters that you're passing. And it doesn't really have to have a return type also. So here I'm saying that take the input x and then find the remainder. If you divide it by 2 and the remainder is equal to 0, print even, else print odd. So we can do this by a function call where we would do even, odd, and I would simply give a number. Let's say I give 24. And if I were to run this, yep, it gave me an error because I did not even run my code block. Yeah. So now it would run. I could also do, let's say 29, and it would give me odd. So this is a very basic one. Let's say we would like to return a data type or we would like to return a value. Then we could have a function which is defined as, let's say I want to add two numbers and I want to return a value. So I would have something called sum. I could have something like sum1. So here I'm taking into parameters x and y, and I am returning the sum of x and y. I could write it like this, and I could then sum of, let's say we have 10 and 15. It gives me 25. So here, if you've noticed, I've assigned x plus y value to a temp variable, and then I'm returning temp variable. We don't even have to have a temp variable. We could have just returned the sum as such. So, yep, it still returns x plus y. And if I wanted to make it a division, etc., I could just simply change whatever I'm doing here. So this is a very, very basic definition of a function. And for I could also assign this to another variable c. And then I could print c. So this is a really useful, it's really useful to know how to define functions in Python. And my colleague, James, will continue on how to use them in actually writing code for solving problems.
Actually, add with, for the sake of time, we're going to move on to add with introduction to a machine learning application using Python.
Yep. All right, let's go ahead and get started. This is going to be a little bit quick. I hope you guys are still awake. Essentially, what we're going to be building today is a student grade predictor. I think this would be kind of fun to see if you guys could use it for your own personal grades, but I would recommend not, because it's not always the most accurate. It depends on how accurate your model is. So now that we kind of like understood what our like syntax, basic Python syntax, we're going to go to try to implement that and create our own student predictor using a linear regression machine learning algorithm. So the biggest thing that I want you guys to know is that linear regression is a continuous supervised machine learning algorithm. So in this case, what we're going to be doing is we're going to be passing in certain inputs, or also known or in this case, attributes. Those attributes are going to help us tell our model what the student is basically like and predict based on what that student's like, what will their final grade be, right? So you guys have a basic two-dimensional graph here, x-axis, y-axis. And here we have basic attributes that we're going to be looking at the students' grades from grade period 1, the students' grades from grade period 2. We're also going to be looking at their number of failures, their study time, all of that fun stuff. So we're going to be looking at a multi-dimensional graph since we're looking at 5 different attributes to predict what the student's final grade is in period G3. So that's going to be on the y-axis. So you guys are going to be seeing all these little dots here. Each dot represents a student object, or also like basically a student record. And our goal is to apply a line of best fit, like an arbitrary line of best fit, to determine a relationship between our attributes or our inputs and what our expected output or what the final grade is supposed to be. So you guys probably have seen this a lot in like Algebra 2, Algebra 1, maybe even pre-calc or calculus. This is basically the implemented model within Python. So it's really cool. We're going to be using this a lot in data science. So the first things first, I'm going to show you guys how to get here. The data set we're going to be using is from the University of California, Irvine's machine learning repository. So if you guys type in UCI machine learning repository, it'll take you to this link right over here. Once you get to this link, here, just for the sake of time, I will throw this in the chat. And if you think I'm going too fast, don't even sweat it because this meeting is being recorded. So if you guys want to follow along now, you can. But if you feel like you're falling behind or anything, don't even worry about it. You can check out our YouTube channel, which will be posted towards the end of this meeting, and you can just access our video there and follow along accordingly. Anyways, so now that you guys have the link to the UCI machine learning repository, what we're going to do is we're going to type in student grades because we want to find the data set responsible for our student performance data. Once you type in student grades and click enter, you're going to find the first link, which is called student performance data. We're going to click that, and it's going to take you to this link basically that describes what our data set is. So we have a student performance data set. And if you guys aren't satisfied with my explanation of what the data set is, you can clearly check out what the data set is right over here. It has a really good description of what the data set is, or in the data set information tab. So essentially, this data set is a multivariate data set. Now, a multivariate data set basically means we're looking at more than one variable in terms of attributes. We have, in this particular data set, we have a total of 33 attributes. What do I mean by attributes? 33 different characteristics that can help us predict what the student's final grade be. Whether it's like you're looking at what's the student's gender, what is their age, what is their family size. You can look at all of these different attributes and help and train your model to recognize them as inputs and give your model a better idea of what their final grade is going to be using those attributes. So when I say attributes, I'm referring to these input values or these descriptions right over here. So for the sake of this example, we're going to be working with integer attributes. This is actually wrong. Attribute characteristics, it's not just integers. Some of them are going to actually have characters and strings, so you can kind of disregard this. But we're going to be working with integers for the sake of this example. And the associated tasks this specific data set can be used for is classification and regression. So we're going to be working with linear regression today. Number of instances, we have a total of 649 instances. What does that mean? Well, it means we have a total number of 649 student records within this data set. And you guys, once we download it, you can see that on your own, but I highly doubt that anyone wants to count that many student records. It's unless you have the time to, which I would be very confused by. I'm sure you would prefer it to compute it the other way. Anyways, we're analyzing from 33 attributes. We're not going to be using all 33 attributes, like I said. I think we're going to be using, I might have to look at my notes, but I think we're going to be using 5 or 6 attributes to kind of predict what the student's final grades are. So the most important thing I want to emphasize is the final grade that we're going to be looking at is G3. Our final grades are going to be represented by the G3 attribute. And the preliminary attributes that are responsible for helping us predict or figure out what will our final grade be, or what influences our final grade, is our grade period 1, which is represented by G1, and our grade period 2, which is represented by G2. So that's basically the attributes. That's the overall understanding of what this data set is. Now, what we're going to do is we're going to go ahead and go into the repository, by clicking the data folder button. And once we click that, I want you guys to click student.zip. It should immediately down a zip folder. And you could literally put that anywhere. If you want to create a separate file, that's fine. I'm just going to store it in my documents for time's sake. And then what we're going to do from there, since we're going to do that, you guys are going to go to your document or wherever you stored the folder, scroll all the way down, click on student, right click, and then you just want to extract all the files in there. If I can find extract all, which is right over here, I'm going to extract it. The reason why we're extracting it is because we need what's inside. Essentially, we're going to be using the student math file. So basically, this CSV file or comma separated value file has all the data we need, and it has all the student records and student grades for students who took a math class, right? So that's what, if you click this, you'll find it. But for this specific, so for instance, if I click this, it's going to open up on Excel. If you're going to notice that the delimiter or the separator is actually denoted by semicolons. Typically for a CSV file, it's the delimiter is a comma, hence why it's called CSV. But for some reason, UCI decided to make it the delimiter semicolon. So we want to take account of that into our code. Now let's go back into our code. Cool. So now that you guys understand where to get the data set from and understand like how to download it and stuff like that, I'm going to break this down into 4 simple steps, or 5. I haven't really counted. First one, we want to read in the first step is to read in all the data from our CSV file. After we read all of our data into our CSV file, we want to split our data into data structures that will hold that data, which we will be using to train our model with. Our third step is going to be creating the model. And our final step is training our model with the train data, and then finally evaluating it or scoring it based on the test data. And by scoring it, we're going to be obtaining or calculating the accuracy of the predictions made. So without further ado, let's get started. The first library we're going to need is, and one more thing. So you guys are going to need to upload the CSV file. So you're going to go to the File Explorer tab right here. Wait till it connects. Once it's connected, click the File Upload button. Click on studentmath.csv, open that. Okay, so another thing is when you upload this file through this option, typically what'll happen is it'll close this file will be recycled after the session ends. So if you want to have it there permanently, you just need to upload it onto Google Drive, and then you just need to insert the link and it'll have it there permanently. But for this sake, since we're working with one session, I'm only going to be uploading it once. Now that we have the data, the CSV file in there, let's get started. So we're going to need to import certain libraries. So we're going to need pandas as Ph.D. Pandas is a library usually used for data analysis and manipulation. So since we're going to be working a lot with data manipulation, we're going to need pandas. The next library we're going to need is NumPy. And NumPy is basically responsible for us. It gives us the ability to work with arrays. Another library we're going to need is sklearn. So sklearn is a really useful machine learning library that's going to provide us with the pre-integrated code for linear regression algorithms. It has a bunch of different machine learning algorithms in it that you could just import and use to train your own model with. So in this case, since we're using linear regression, you just type from sklearn, we're going to need import linear_model. Now that we have a linear model, we're also going to need to import the shuffle function. So from sklearn import, .utils import shuffle. Cool. So those are all the libraries we're going to need for now. By the way, a quick side note, I always have to click the play button to run it. Just click Shift Enter. It'll just run the cell and it'll also create a new cell. So let's go ahead and get started. First step, let's read in the data from the CSV file, okay? So when we're reading the data, let's create a variable called data, which will have the data table. So data equals pd.read_CSV, and then we just pass in the name of our CSV file, which is studentmath.csv. And we have to make sure that this is what I was saying earlier, our separator we have to specify that it's denoted by a semicolon. If we don't do this, your data will be formatted very strangely when you're putting out the table, and it just becomes wacky. So then if we want to see what it looks like in the table, we just call data.head and we print it out. And when I run the cell, you guys will see that we have our table right here. And you'll see that 33 attributes technically exist within this table, but some of them have been omitted just because when we're printing it, it can't just fit the entire frame. So we're not going to be looking at all 33 attributes. We're going to be looking at only, I believe, a couple of them. And there, I have it in my notes. I'm just going to check which ones I need. But now we're going to be basically, we're going to be updating our table to store the attributes that we need. So the attributes that I personally want to use, I'm going to be storing this within a list of lists because you want each attribute to be represented through a column. I want grade period 1, grade period 2, grade period 3, which is our final grade. So remember, grade period 1, grade period 2, final grade. And then let me see my notes. I wanted study time, failures, and absences. Study time, failures, absences. If I spelled this right, it should compile. So if I print this table now, you'll notice that our table has been truncated and it's omitted all the columns we don't need. So we're looking at these following attributes: grade period 1, grade period 2, grade period 3, study time, failures, and absences. And this is the count. So these represent the student's current score. I don't know what the score is out of. You would have to look into the repository information, but this is basically just a point-based value. And then this just represents the number of hours. This is the number of total number of failures the student has encountered, and this is the total number of absences that particular student has encountered. So we finished the first step. We read in the CSV file. What is the next step? The next step is we want to specify what is the value that we want to predict. So we want to predict our final grade, correct? So we're going to store that within a variable called predict in G3. Next, we want to create two data structures. We're going to be using arrays to store our training set data. So I'm going to do capital X equals np.array, and essentially I want to store all of my attribute values, all my attributes. So all of this, except for G3, because X is going to be our attributes that we're using as our independent variables that we're going to be using to train the model. Y is going to be G3. That's our output. So on the vertical axis. So anyways, sorry. np.array data.drop, and then we're going to pass in predict. I believe that's, yeah, if my syntax is correct, I think. And oh, my mistake. We need one model. And then finally, we're going to need y, which is np.array. And then we're just going to need data predict. From there, we're going to be splitting our data into the training data sets and the testing data sets. So you're going to have to follow this exactly like syntactically correct, because you'll throw an error if you don't. So we separate X train, Y train, X test, then, or X train, X test, Y train, Y test equals, and then now we have to do, split the data. So you're going to do sklearn dot model selection, and then dot train test split, I think, yeah, train test split, and you're going to be passing in your X, Y, and we want the test sample size to be 10%. Oh, sorry, this is not what I want. Test underscore size. That is still not what I want. Test underscore size. Yeah, that's right. Cool. So essentially what this is doing, and I don't know, I hope you guys can see this, but what this is doing is basically it's splitting up our data so that 10% of our data is going to be stored in X train, 10% of our data is going to be stored in Y train, so, and 10% is going to be within X test, and 10% is going to be in Y test. The reason why we're doing 10% of our data at a time is because we want to train our model to learn. If we do 100% of our data all at once, what's going to happen is the model is going to memorize the inputs. It's basically like going to be recognizing everything. It's not going to be truly learning. So we want to make sure that we randomize this test sample every single time. So so that it's constantly learning and we're achieving a certain accuracy. So let's quickly run this to make sure I don't have any syntax errors, and I do, and that is because I know why. It's because I have an extra parenthesis right over here. I'm gonna comment, oh, whoopsies. Perfect. So now we split the data successfully. So now that we have read in our data, we split our data, we're gonna go ahead and start by creating our model. I'm gonna call my model linear. And I believe I'm gonna call linear model dot, and we're gonna apply linear regression. So now that I have linear and I have my linear model created, we're gonna basically be fitting our model onto our test data. So all I have to do is call linear.fit and then x underscore test, I believe. Oh, no, we're training our model, excuse me. So right here, we are training our train, y underscore train. So this is going to be basically fitting, it's going to be applying our line of best fit onto our training data. So from our X train and Y train data that we already mentioned earlier. Now, the biggest thing you guys are going to want to see is we want to know how accurate is our model, right? So basically, we have to obtain that accuracy. So let's create a variable called accuracy, and we do linear, and we want to score our model to obtain that accuracy. So we do accuracy equals linear.score, and then we apply our test training set, which is represented by X test and Y test, to make sure that we have the comparison. Once we have that, we want to make sure that we convert this to an actual accuracy. So this is going to be some sort of number like 0. I don't know, 0.9 or 0.9 or 0.8 or 0.7. So we want to convert this to a percentage, correct? So what we do is we do accuracy equals accuracy times 100, and when we and then if we want to round it, because I only want it to 2 decimal places. So if I want it to 2 decimal places, I do accuracy equals accuracy dot round 2. And if I want to see what my accuracy of my trained model is, I'm just going to use an F string, and I'm going to say accuracy is colon, pass in that, pass in accuracy. Then I pass in the modulus sign because we want to do that. So I print it out. You can see that the accuracy of my model after training it on 10% of the data set is 93.23%, which in my mind is actually really high. It's a pretty good model. I'm not going to show you guys how to save this model just because we don't have that much time, and I want to make sure you see the end product soon enough. But there's a way to save this model to make sure that you always have that accuracy of 93.23%. Because if you rerun this data set, what ends up happening is that the model will be retrained again on a new sample size of 10% of the data. So that your accuracy is bound to change. It could be lower, it could be higher, but to avoid that, you need to learn how to save your model, which we can figure out in another workshop. So now that we have our accuracy, you must be wondering, okay, well, I know what my accuracy is. I want to see what it looks like when I compare the predicted values with the actual values. So what we're going to do, create a variable called predictions, and we're going to apply linear.predict, and we're going to predict it on X test. This is basically what this is doing is we're telling our model to predict a value based from this X test data. Okay. So then we're going to loop through it. So for every, I'm going to say X in this case. So X represents for each student record within the range of your length of your predictions, because that's the number of predictions we're making. You want to make sure that we're just going to print everything out. So now when we print this out, there's a couple things we're going to need to print out our predictions predictions at X. We're going to also need X underscore test of X. So, and then this is going to show all the values specifically for each attribute. And I'll explain that in just a bit. And finally, you do Y test of X. Sorry, that should be square brackets. And now that's done. If I run this code block, you guys will see now that our what the predicted value is denoted right here. What were the test values that we used within our input are represented right here. and our final value, or what our expected value, is denoted right here. So you might be thinking, this is way too many decimal places. It's not clean. So if I just want to round that real quick to 2 decimal places, it'll be a lot more legible. So now you can see here. So our model that has an accuracy of 93.23% predicted the final grade to be 11.93 for this student when their actual final grade was a grade of 13. And you can see that this student had his first grade period, he scored a total number of points of 11. Second grade period, total number of points of 12. Our third attribute was our study time. So he studies typically for 2 hours. Failures, this student has not failed within these 2 grade periods. And number of absences, well, we can see that he might have been sick a lot, or he might have missed a lot of classes, because he has a total number of 10 absences. So that's just for one student record. If you continue to go down, and keep in mind, this is only 10% of the sample data set. That's why you don't see all of the total number of values. So you can keep on making that comparison. So here we have our predictor saying, okay, this student scored a total of 12.2 points, but our actual final grade was 13. So you can see we're relatively close, but we're not 100% accurate just yet. To achieve that 100% accuracy, you just need to keep training your model and make with new data, and until you improve and increase that accuracy. Then you can get more closer predictions. But yeah, so now that's basically what the final output looks like. You might be thinking, well, this is just a bunch of numbers. What does this actually mean to me? Well, let's try to improve this by adding some more visuals. So let's try to get this onto a graph, and it's actually really simple. So to get this onto a graph, we're gonna have to import another library called matplotlib, and then I believe, if I'm not in my notes, we need pyplot. So yeah, matplotlib.pyplot as PLT. That's what it's going to be called. And from this matplot library, we're going to need style. Style will just help us format our graph using ggplot. So I'm just going to rerun this. You're going to need to rerun this code block because we just added 2 more libraries. Now that we added 2 more libraries, let's go ahead and graph this. So to graph this, it's really simple. Well, keep in mind, we have 2 variables. We have the independent variable, our x-axis, and our dependent variable, our y-axis. So let's see. I want my independent variable, or my x-axis, to be grade period 1. I want to see what is the relationship between the first grade period and the final grade. If I do x equals g1, and I do style.use, or is that, yeah, style.use, and I'm going to be using ggplot to format this graph. That's the plan. And then once I apply this style through ggplot, I want to make sure I scatter my data. So I'm using plt.scatter. We're just using, I believe, we're applying data of p, and we're going to be applying data of x, or excuse me, this should be data of x. I was looking at my example. Data of x, and then here we're going to be doing data, and I believe we're going to use, what are we going to use? G3 as our final grade. Cool. So that's going to be scattering our data with respect to what our values are for G1 and G3. Next, we want to label our axes. So if I do plt.xlabel and I pass in, let's see, what do I want to pass in? I pass in x. And then I do plt.ylabel and I label this to final, grade. And finally, I do plt.show. I run this. You guys will see that our final result is our graph that shows a linear relationship between our grade, all the students' points earned within the first grade period and all the students' points earned within the final grade period. So as a whole, that's essentially the entire model. And I know I went really fast, but just because I didn't want to take up too much time, you guys are free to go through this workshop again because it will be posted on YouTube. But yeah, that's about it. That's the implemented version of linear regression. And this is our final student grade predictor. That's it. For the rest of the meeting, we'll be taking Q&A. So if you guys have questions, feel free to ask them now or forever hold your peace.
As a freshman, what would be like a good resource to start learning Python if like ASU doesn't offer
Intro to Python.
undergraduate like Python classes?
Yeah, that's a really good question. So first of all, you're in the right place. Usually with student organizations, they'll help you get started as much as possible. When I didn't have any freshman courses about or artificial intelligence or anything when I was a freshman. So what I usually did was I ended up going online and using like sources on YouTube videos, watching how to really get like set up and introduced into machine learning. So I would just say your online database is something that'll help out a lot. You could just Google how to get started. That's exactly what I did.
Thank you.
Yeah, no problem. So where is the recording going to be posted again? It'll be posted to our YouTube channel. I will get the link unless, James, do you have the link for that?
To the YouTube channel. Yes, I will post it.
Cool. This video will be uploaded by maybe I don't know, in the end of the week or in the coming week at least. So you guys can watch it there. And if I was talking too fast, I apologize again.
Also, a good place that you can learn a bit of Python is, if I can find it, Google has a nice introduction to Python page. And it might be a bit outdated. I'm not sure, I haven't looked in a while. But this was pretty helpful when I started.
Any other good sites for data sets that you would recommend? So I personally like, I haven't explored too many just yet. Usually in my classes, I'm either given the data set from a professor or I just go and do some digging for my own. I'll definitely have to do some research, and if you're in our future meetings, I'll have to let you know, Tanner. But I think the reason why I like the UCI's machine learning repository is because the data is sometimes a majority of the time pre-processed, so it's pretty clean. There's not any like loose values or anything that you have to process. So
Or if you wanna like get started into data science, you always can go to Kaggle. I'll post a link if you want. Yeah. So Amit just posted it. So there we have a lot of good data sets and notebooks to like get started if you don't have any idea how to get started. And they have discussion forums, so pretty good site too, at least for data science.
So our next meeting, as of right now, is scheduled for November 5th, and it's a little bit more of an advanced meeting. That meeting will be led by our technical director, Jay Shah, who will be giving a presentation about his an introduction to convolutional neural networks, or CNNs. So that's something, if you guys want to like really test yourself or challenge yourself, I would highly encourage you guys to come to that meeting. Even if you don't have too much experience within Python or machine learning, it's still really cool to see what the end product's like and learn a little bit. So I highly encourage coming to that. James, did you have anything you wanted to add to that, or?
Nope. I think that this may be a good place to conclude.
Cool. Apart from that, if you guys have no further questions, you're free to go. Officers, if you guys can stay just for another 2 minutes, that'd be awesome. It was nice meeting you guys.